Let's take a look at while for. Here's the fourth example. This one is going to use a so-called sentinel value of 0. This loop is going to repeat until num equals 0. But this time we have user input. As you can see, we're using the input function, and we're going to allow the user to enter an integer from the keyboard. And we're going to have a loop. Look at the while condition here. While num is not equal to 0. So if the user doesn't enter a 0 here, this loop will enter. If the user does enter a 0 initially, the entire loop will be skipped. Whatever gets entered will be printed out here. And then we ask the question again. We repeat the input here inside the loop. So let's give it a try. I'll enter a 0. Loop stopped immediately. Right, that made the condition false right away. So the loop stopped. Try it again. I'll try 1, try 2, try 3. It'll just keep going. I can enter 22. As long as I enter an integer, it's going to keep going. As soon as I enter a 0, it'll stop. So 0 is what we call a sentinel value in this case. Okay, the so-called sentinel value. Now, we could make this a much more useful program. What I could do here is, just before the loop starts, I'm going to add a couple of variables. I'm going to specify a variable called count and give it a value of 0. And this is going to be a special kind of variable which we call a counter. I'm going to keep track of how many numbers I enter. And then I'm going to create an accumulator, which I'll assign the value of the total to that, a variable named total. So this is going to be an accumulator, and we'll use this to add up the integers that are being entered. Okay, now I have to specify both of these before the loop starts. They have to be initialized to 0. Whenever you want to count something, before you start, of course, the count is 0. And if you're adding up some numbers before you start, the total is 0. So this is how you initialize them, set them to 0. Now, as my loop is cycling here, what I want to do is keep track of the numbers that were entered. So what I can do, every time a number is entered, I can add one on to the count. I can also accumulate the total by whatever the number was. So I could, down here, I could say total, not in caps though, total plus equals the value of num. We'll add the value of num onto the total. So here we're incrementing. So this is incrementing the count by 1. Sounds like Sesame Street. The count. Here we're accumulating by the value of the input variable. So this is accumulation. Now, when the loop is done, we should be able to report what those values are after the loop finishes. So down below the while loop, not tabbed in, this line is not going to be inside the loop. We could print the results down here. We could say that was count integers total. So we'll just show what the results were with one line after the program is done. Let's give that a try. So here we go. Okay, I'll try make this real easy. 1, 2, 3, 4, 5, and then my 0. entered 5 integers, and the total is 15, which is correct if you add those up. That is a total of 15. Well, it turns out that that's not a bad, useful little program if you want to add up some numbers and keep track of the count. Of course, we could get the average after doing this, right? Dividing the total by the count. So all kinds of things that we can do to add on to this. Is everybody okay with why that one runs the way it does? Yeah. Any question? Any question about that one at all?
Nope.
Okay.
I'm just curious about like use cases. I mean, I understand the example that you have on the screen, but what would be a use case where you find these type of loops? Like what's the program doing at this point? Or what's the purpose?
Well, in this particular case, it's basically operating like an adding machine, I guess.
Okay.
Right. We could. I just went with 1, 2, 3, 4, 5, but I could have been entering any numbers at all and totaling them out. You know, as long as they were integers. So in this particular case, it's like an adding machine.
Got it. Okay.
Anybody else have a question about that?
Yeah, can you just explain to me, like when you hit 0, why did it automatically add the totals? Where is that in the code? Is this num equals integer input enter at the end integer or 0 to quit? Or where's, oh, is it count, the last line, right? Print?
That's right. That's right. Right here. When I entered a 0 on this line, the loop stopped.
Okay.
Yeah. Yeah, you always have, when you're using a while loop like this, you always have to have this. This is called the priming statement here. You have to have some value to test here, right? So in this case, this is called the priming statement. And then this is called the continuation read to continue the loop.
Okay.
All right, like, you know, where this could come in handy, you could add up the hours you worked in a week, right? You could enter your hours worked for the, you know, 5-day, 6-day week. You could add them up. Then you could enter your pay rate, and you can determine what your total pay, your gross pay should be. Programs like this have all kinds of applications. So if you're okay with that, any more questions about that one? Okay. One more while loop to take a look at. Let's take a look at another one here. We'll shut that one down. And we'll take a look at while 5. And here's an example of another example of what you can do with a while loop, and that is input validation. This is very important when you're trying to keep track of data. In the real world, you want to make sure that all your data that your business is storing in its database is accurate. Well, you can do something called input validation with a while loop, which basically forces the user to do the right thing with the input. And in this particular case, we're going to force this program will force the user to enter an odd integer. So what we're going to do is we're going to ask the user to enter an odd integer, and then we're going to look at this condition here. While the remainder, when we divide by 2, is not equal to 1. So in other words, while it's not an odd number, right? Because when the remainder divided by 2 does equal 1, we know we have an odd number. So this should continue to cycle until we enter an odd number. As soon as we enter a number, we'll report what was entered. And then we have another read down here. This is that continuation read. It's very same. Actually, I copied this line up here and tabbed it in to make it inside the loop. So that's the continuation read. So let's give it a try, and you'll see the concept of input validation, I'm sure here. As soon as if I enter an odd number, the program is over because I complied. Let's see what happens if I don't enter an odd number. 12, 14, 56, 1000. Just keeps going until I enter something odd. Okay. Everything all right there, Todd? Sounds like
Yep. No, I got it.
okay. So, does everybody understand how that one works? We're forcing an odd number. And this is a simple example, but we could force any other type of input. Like for example, let's say you were a program had to enter an SKU number in a retail operation, or maybe a part number. Well, you would allow only certain format for that input, and you could use an input validation loop like this to make sure that only good input was entered. I'm sorry, go ahead.
Oh, I just, you know, while you were doing this validation, I was wondering if this is something that could be used for like a password entry. Until you enter the correct password, you're stuck in that loop.
Exactly right. Exactly right. Typically, you get how many tries before you get locked in?
Yeah.
Usually it's 3, isn't it? Seems like 3 tries before you're locked out is pretty commonplace.
Yeah.
For passwords. Yeah, so what we could do is every time a wrong number was entered here, I could have counted. In this case, I did enter 4 wrong numbers. We could have kept track of the count, and after 3, we could have said, come back later when you know what an odd number is or something, which could be insulting. But yeah, you're quite right. Password validation would work just like this as well.
Okay, thank you.
And that would be on a program on a web server, right? Probably written in PHP or maybe JavaScript. Okay. Well, that's while loops. You can do more with while loops. The whole thing about a while loop is, as long as this condition here is true, the loop will continue to cycle. It'll continue to repeat. Let's take a look at another type of loops. A for loop. We'll get the ebook back up again here. And the next type of loop is a for loop. For loops, my personal favorite. If I have a choice, I'll use a for loop for a program. Sometimes a while loop is better for certain types of operations, but for loops are great when you know exactly how many times you want a loop to execute. For a specific number of iterations, it's the big computer word for loop cycle. It's called an iteration. If we know in advance how many times we want that loop to cycle, a for loop is a good choice. But it also has some other interesting uses as well. So let's see, I have a folder here with some for loops in. I've got quite a long list of examples here. Let's try it with this first one here called for loop list. Okay, here's the first one. And this one introduces the concept of a list here. If we have a comma-separated list of items inside square brackets, that creates what's called a list in Python. Here's an example here, a comma-separated list of items. And you'll notice we've got a couple integers, a string, another integer, and then a Boolean value true here inside the square brackets. Now, this is a bit unusual. Most programming languages require all of these types to be the same in a list. But Python allows you to mix them up like this. Now, anyway, how does that for loop work? Well, it's got the keyword for here. And then I've got for n in this list. Print the value of n and cancel the new line and print a space. Now, I've used the variable n, but I could have used anything at all here. And any variable name would have worked. The secret is that as the loop's going to cycle here, each element in the loop, and that's the term that's used for the parts of a list, each element in the list will be assigned to n as the loop cycles. So first time through the loop, n is 10. Next time through the loop, n is 8. Next time through the loop, n is Guido. So here's how it runs. It just prints them out all in one line. We loop through the list. Any question about that one?
Nope.
Okay, let's try another one. Let's take a look at the next one here. Another one with a list. This time though, what we'll do is we'll add up the numbers. So we've got an accumulator called total set to a value of 0. And we're going to list through a list. We're going to loop through a list of ints. As you can see, I've got all integers here separated by commas. Once again, I'm using n. We're going to print the value of n, and we're going to add the value of n onto the total with the plus equals operator. And then after the loop finishes, notice this line's not tabbed in. That means it's outside the loop. We'll print the total. So here's what that one looks like when you run it. Just prints them all one by one, all in one line separated by a space, and then prints the total after the loop finishes. Okay, so that's one thing you can do with the for loop is you can go through a list one by one, element by element through the list. Any question about that one? Loops are kind of fun.
I'm sorry to keep asking the same question, but that one and the one before, I'm having a hard time understanding that, like the use case or the application. Like I get the in this one the accumulation of the values, but what is the purpose of printing the list all in one line? Why are we going through the list and assigning the value to the variable all in one line and not as separate line items?
Well, we could print each one on its own line if we wanted to, and just have to take away that end operator. I'll just bring that one up again. Yeah, it would be no problem to print them, I mean, all in one, on different lines. I'm just trying to save screen real estate by printing them all.
Oh, okay.
But the whole idea here is if you have a list of items, now that list of items could be generated by 200 lines of code that's above here, right, in a more complex program, right? So the whole idea is we're just trying to get through this list of items that we somehow have. In this case, we just generated the list. We hard coded the list here instead of making it the program.
Can those lists be variables?
Yes, they could be variables. That's right. These could all be variable values
That you pull from other places and just...
Exactly right. We will cover that. We actually do that in chapter 7. Chapter 7 is devoted to lists, entirely all about lists.
Okay.
Yeah, it's a very interesting chapter. Don't feel bad about asking those questions, though, Val. That's fine. I'm glad you're doing that. Let's try another use of a for loop. This time, we're going to use the range function. Notice I've got here for x in range and then 8. Round parentheses, not square brackets, by the way, right? And what we're going to do is we're going to print the value of x and all on one line here. Well, we're going to find out that this is just the same thing as having this in a list, because range 8 really means numbers from 0 to 7. So when you see range 8, it means x is going to take on the values from 0 to 7. It never does get up to 8. You get 8 iterations of the loop, though. Notice that the loop is running 8 times. We get eight outputs here. So if you want something to happen 8 times, this is a good way to do it. Like in this particular case, I could change this completely. I could say print hello. And I could comment this line out, run this program again, and it's going to print hello 8 times. Whatever I put inside the loop is going to run 8 times. Obviously, that's kind of silly, but we could have dozens of statements in here that would run 8 times. That's the whole idea, repeating. Why does this repeat 8 times? Okay with that one?
Yep.
Okay. Well, that was an introduction to the range function. Let's take a look at another example with the range function. You can specify 2 values inside the parentheses after the range. And when you do that, the first number is the start. And the second number, well, we know it's not the stop. It's actually, it'll stop at 1 less than that. So really, that's going to go from 10 up to 15. We won't get to 16. That's the way the range function is programmed by Guido, I guess. So it's start and stop minus 1 when we use 2 numbers. So that's what we get here.
In this one, you put X. Sometimes it's num. That X is just completely arbitrary, correct?
That's right. It could be anything at all.
Okay, I just wanted to make sure.
Yeah, yeah. I could put AB there and AB there, whatever I put here, right? Yeah, whatever this variable is, it's going to take on each value in the range.
Because everything stays kind of consistent, so I was making sure it's not a rule. It's just literally arbitrary.
You're absolutely right. You can make up your own variable name there. Yeah. Good question. Let's look at another one. Next one also uses range, but this time we're going to see 3 values inside the parentheses. Well, when that's the case, you get the start, the stop minus 1, and the third one is a step indicator, a step value, by how much it's indicating how much the values are going to change. So in this case, 10, 21 means they're going to go from 10 to 20, but with a step of 2. And so you'll see in this case that we get from 10 to 20 every other number. Step of 2. If I were to change that step, well, I could actually do more than that. I could change this to 101 and make it a step of 20. Anybody want to take a shot at what that would do?
Increments of 20 up to 100 from 10.
Yeah,
so
that's right. That's right. Very good.
So go to 90.
That's right. It stops at 90. That's right. 90 is the last one that's printed. It does get up to 100, but it's not going to print that one. Okay, increment of 20. For loops are great for getting a whole lot of numbers in a hurry into your program, because particularly with this range function. We actually have a few more. Let's try this one. No, here's one that's a little different. Look at this one. You can go descending. You don't have to always go in the ascending order. You can descend as well. Take a look at this. What we'd like to do is go from 100 down to 0, decreasing by 20 every time. So what do you think has to go in the parentheses this time?
100.
Yeah.
So 101. No. 100 down to -1.
Excellent. Has to be 1 less. That's right. Outstanding. And what's the step?
20.
Yeah, almost.
Not 20?
Not exactly 20. Plus 20 or minus 20?
Oh, minus 20. Yeah.
Exactly. It's got to be minus 20. Right. So if I remove the comment here, we'll give this a run. Let's see what we get. All right, there it is. From 100 down to 0, decreasing by 20 every time. Okay. Hope you're okay with why that works that way.
Mm-hmm.
You can have 3 values: start, stop -1, and step. A couple more. Look at this one. Number 5, with the range operator, range function. Remember, all that really means is do something 10 times. So, I mean, this is kind of silly, but we could print Python rocks 10 times. Whatever we put inside, whatever's indented underneath the 4, is going to run 10 times. You notice I'm not using this at all. Not using the n at all here. Might not need the loop control variable at all. Just want to do something 10 times. This will work fine. Let's try another one. How about number 6 here? Missed it. Okay, here's an interesting one. This particular program is going to find and count multiples of 29 between 500 and 1,000. Which is a weird thing to do, but we can do it if we want to. So we're going to set a counter up to 0, as we always do, initialize counters to 0. We're going to go from 500 up to 1,000, so that means I got to make this 1,001. It's got to be one more. And now inside, we're going to test the value of n by dividing it by 29, and if the result is equal to 0, the remainder is equal to 0 when we divide by 29. We know we have a multiple of 29, so we'll print it out, and then we'll add 1 onto the count to count them. And then after the loop's done, we'll indicate how many we found. So let's see what we got here.
So you can have an if without anything else, like the else or the...
Sure. You don't have to always have an else with an if.
So it's basically if this, do it. If not, then nothing.
Exactly.
Okay.
Exactly. If not, just carry on to the next line. What if we had another line in here? We would just carry on to it, right? If we had a line in this position here.
Okay.
So apparently there's 17 multiples here. All of these numbers divide exactly by 29. We could have added them up. We created an accumulator. We could have added them up. We could then find the average. We could do whatever we wanted to do with those. Let's look at one more example here with the range operator. Well, here's a good one. And Val, maybe this will help you to for something that's actually practical for a change instead of just doing meaningless examples here. We could print out a table of Celsius and Fahrenheit temperatures that are equivalent. So what we're going to do is we're going to use a variable C. I don't know why I went for C. Probably T would have been, oh, and C is the Celsius. I'm thinking C is the Celsius temperature. F is the Fahrenheit temperature. So for C in range, now we're going to go from 60 down to -40 by -10 each time the loop cycles. And we're going to calculate the Fahrenheit temperature with the formula 9/5 times Celsius plus 32. And then we're going to print each temperature formatted with 2 decimal places, 0.2f, but we're also going to print them in columns 12 characters wide. So you get a nice table look to the output. That's what, if you put a number in front of the period, that indicates the width of the field or the width of the column that the number is going to be printed in. So let's try it. Let's see what happens here when we run this. There it is. That's the table of equivalent temperatures in Celsius and Fahrenheit. And this column here is exactly 12 characters wide. You can verify that if I put my cursor right here. I'm going to count as I press my cursor right arrow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's exactly 12 wide. And it would be the same up to, well, let's count here too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, something's wrong. No, nothing's wrong. This comma inserted 1 extra space, right? So it's still working okay. 12.2 means show 2 decimal places in a column 12 characters wide.
So if you wanted to get rid of that space, you could do the sep equals.
That's right. We could do sep equals nothing. Exactly right.
And could you do, instead of the field width, I mean, I guess this right aligns it, but if you do the tab, the /T.
Yeah, the problem with tabbing is you get into difficulties when you don't have the same number of characters to display. Like here, it's only going to print 3 characters, and so that's going to mess up the tabbing. Unfortunately, it won't look good. This way, we've got all the decimal places one underneath each other in the column, which is a superior way to show it. Good question, though. And look, there's a number set that we know, right? We know that 32 Fahrenheit is the freezing point of water, which is 0 in Celsius. So we know this is correct. And if you've ever lived up north or been up north in the wintertime, you would know that this is the one place where the 2 temperature scales coincide. So if it's 40 degrees, if somebody asks up north if it's minus 40, somebody asks for the temperature and it's minus 40, and they'll say, is that Celsius or Fahrenheit? The correct response is both, because it's the one place where the 2 scales are the same, minus 40. Used to work on the ski patrol, and I've skied in that weather.
Nope.
Okay. So that shows you that there are some uses to this. We could print out tables of squares and tables of cubes, that sort of thing as well, with for loops. A really easy way to generate the output. Now we could have done this with a while loop, but to me it's a lot easier to do with a for loop. All right, good. 2 more examples here. You can put loops inside loops. Sorry?
If you did that other one with a while loop, you'd actually need to know some information, would you not?
You'd have to start with an initial value of Celsius, which is basically what we did there, I suppose. We can do it if you want. We could try it.
I'm just curious, and my brain isn't switching it over.
Okay, well, all right. I'll tell you what. Why don't we give it a try? See if we can
Although this nested loop is what's been beating me up, so I'm happy to go to that too.
All right, we'll go back to we'll try it with a while loop if we have time at the end. How about that? Here we go with the nested loop. Nested loop simply means that you've got loops inside of other loops. In this case, you can see that we're starting off with a for loop, but I have another for loop inside that for loop, tabbed in, of course, which would have to be. And that's called nesting, if you put one loop inside of another. And it's not unusual at all in computer programming to do that. So the outer loop is going to go from 0 to 9, right? And this inner loop is also going to go from 0 to 9, but it's going to use a different loop control variable. I used M for it instead of N. I just chose the next letter in the alphabet. And then what we're going to print out is the value of N and M. And then we're going to separate them with nothing and a couple of spaces, more than I could have used, I suppose, a print format, but that's a pretty crude way to get some spaces in the output. And then after that inner loop cycles, goes through its iterations, we're going to print a blank line. So what this does is it does give us sort of a table. Here's the output. Look at all the output we got from that little bit of code. Hardly any code at all. And look at all the output. That always gives me a buzz. I just got a loop buzz. I think it's so cool that you can get all that output with just a little bit of code by using nested loops. Pretty nifty, huh? Notice it goes from 0 to 0.9 and then all the way up to 9.9 here. Well, it's not 0.9. I've got a colon in there instead, but amazing how much output you can get, right? See, so the first time through the loop, the outer loop, first time the outer loop cycles, n is 0. M starts at 0 and goes all the way up to 9. Then the next outer loop cycle starts with n, as in Nancy, being 1, and then M starts over again at 0 and goes all the way up to 9.
Okay.
So the outer loop runs 10 times. The inner loop runs actually 100 times. Lost my output there. Okay. Kind of crazy what you can do with nested loops. One more example that might help you even more than this one, and it generates some really cool output. Once again, I've got nested loops here. This time, the outer loop is going to go from 1 to 13. We're going to start with 1 instead of starting at 0. So we'll put 2 values in here. And the inner loop is going to go from 1 to 13 as well. And what we're going to do, what we're going to print each time is we're going to print the product of n times n in a column 5 characters wide. That's what 5D means. We're going to the D means formatted as an integer, and the 5 means in a column 5 characters wide. And then we're going to cancel the new line. So it should, all of these should print out on one line. When that line is finished, when that inner loop finishes, we're going to print a print to finish the line here, because we aren't finishing the line up here. So this will finish the line, and then the outer for loop will start its next cycle. So what you get is a very interesting output. You get a great multiplication table. And you could determine the product of any two numbers all the way up to 12 by 12 simply by looking at the intersection of the column and the row. So for example, if you wanted to know what 7 times 9 was, you would go to the 7 row and come over here to the 9. 7 times 9 is 63. Great way to learn multiplication tables.
Like you did on the other one, this is where my head's been having trouble with these. Like you did on the previous one, can you point from code to table, so I can wrap my head around what went where?
Yeah, I'll try. First of all, look at the outer loop. It's going to run from 1 to 12, right? We never do get to the 13. It runs from 1 to 12. So that's going to run 12 times. But each time it runs, the inner loop is also going to run 12 times. So we're going to get the outer loop value multiplied by the inner loop value. So that's where we get the values that show up in each row. So the first time through, you get 1 times 1, 1 times 2, 1 times 3, all the way up to 1 times 12. Then the outer loop starts again with n having a value of 2, and we get
2 times 1, 2 times 2.
2 times 2, 2 times 3, and so on, right?
Okay.
The inner loop starts all over again every time the outer loop runs. And each of these is in a column 5 characters wide. Just check that here. 1, 2, 3, 4, 5. Exactly 5 characters wide. That's the 5D. N times n, m, of course, is the product of the two.
So n's producing the rows.
That's true. That's
Okay.
right. That's a good, in fact, if I were doing this with a little bit more complexity, I'd probably say for row here and for call for this one, COL for call.
Okay, that's I needed that. Okay.
Okay. Yeah, that would actually be a nice improvement on the program. Typically, I would do that. Row and call here, and then put row and call here. Something like that. That's actually a little bit better. We'll try it that way. Yeah, it runs the same way.
Okay.
Now, this, if you have a younger sibling who's trying to learn the multiplication table, this is a great thing to have. You know, you could take your snip, right? Get your snip utility, the snip tool, and you could snip that thing. Just snip the table part,
Well, that's really cool. I didn't know that tool existed.
Oh yeah. Oh yeah. Yeah. It's great. Great if you got a photograph and you don't want to put everything that's in the photograph. You only want part of the photograph, right? So there's the table. Now you could print that out, right? You could save that to a file, and then print it and give it to your younger sibling who's just learning their multiplication tables, younger member of your family, and they can tape this on their bedpost or something and learn the multiplication tables.
It's a really cool tool.
It's much better than the, I remember when I was in elementary school and we had these little notebooks, and on the back of the notebooks you had all the multiplication tables. 1 times 2 is 2, 1 times 3 is 3, etc. And then repeated for all the different numbers. But this is a far superior way of doing it by seeing where the rows and columns intersect. Pretty cool. And look at all the output we got from just a little bit of code. It's amazing. Look at all that output from just a little bit of code. Loops are awesome. They're fun to work with. You can do tremendous things with them.
I have a question.
Yeah, just go ahead.
Oh, sorry. So I see in the code that you're formatting your column to be 5 characters wide with the 5D.
Right.
But what is giving you the right alignment? I mean, I don't see anywhere in the code.
That's what happens by default. Yeah, they're right aligned by default with format.
Okay.
Yeah.
What if you wanted to center align it, or if you wanted to, like, if you wanted to change the default, what's the statement, or is there a statement for that?
Yeah, it's a little tricky though. And I don't actually recall it off the top of my head, but it could be done. In a lot of programming languages, you'd put a -5D, but I don't think that works in Python. I'm going to test it. I'm pretty sure it's not going to work out. No, it didn't change anything. Well, wait a minute. Try a new window. Yeah, didn't change anything. So it's going to be done another way, and I'm not sure what it is.
It's not a big deal. I was just curious.
Yeah, it's probably another function. It's probably not format.
Okay. Thank you.
Okay.
But why would it have, whether it did what you wanted or not, why did that not change anything or crash?
That's also a good question. Yeah. Weird. Didn't seem to bother it at all. I suppose what we could do is just print the first number without any formatting, and then the numbers after that with formatting. And that would left align, right? Like we just print the first number always without any format, and then left align all the others. I think that would work. But that's also a little bit tricky to code, I think. Okay. Got one more example I wanted to show you, and it's not, it's working with Turtle. I don't know if you've noticed that the textbook finishes up with information about the Turtle module. And so I'm going to open up this program here. It's a Turtle program written in Python. There's various modules that we can import when we're using Python. Like when you install Python, you get a bunch of modules by default that are part of the standard distribution. But you can also import hundreds of other modules that have been created by many Python programmers that follow Guido. And one of them is this Turtle module, which is for doing Turtle graphics. And you can do some pretty complex stuff with it, actually. But look what's going on here. We're creating a whole bunch of constants, and we're going to set an animation speed. And you could learn all about Turtle online if you want, and I encourage you to do so. Check out what you can do. You can do Turtle art. Crazy little things like that. And you can change the colors too. And I have messed around with that. Unfortunately, I don't have them with me. I might have something back on our page though. Let's just see if we do. Back in module 4, is there anything about turtle?
I don't recall.
No. Yeah, a little bit about Pygame.
Oh, I looked at that.
Yeah, Pygame is a module that you can use to make games, and there's lots of free books on that. Yeah.
Real quick on that Pygame, at least for me, one of the links, the second video, it's broken. It doesn't open for me. It's not open on YouTube.
Oh, that's too bad.
I don't know if anybody else is having the same issue.
Yeah, I'm sorry to hear that. What happened?
One of the things I had to copy the link instead of just click. I had to copy links and bring it over.
Okay, that's too bad. But you can do some interesting stuff with Pygame, and there's a lot of free ebooks that you can get, PDF files, and you could work through them and learn a lot of Python if you do. Basically 2D games, of course, nothing sophisticated like Call of Duty or anything like that. Okay, well, I did want to show you, I guess, a little bit about that one problem. And that was the, was a question about the assignment and this one here. Sorry, here's the assignment. Make sure you do those preparation programs, by the way, they're worth points. Okay, so here we want to use the while loop to multiply integer factors entered by the user. Program should continue to accept integer factors until the user presses enter. Okay, so notice we're entering 3, 5, 6, 8 here. And it's multiplying. Obviously, 3 times 5 is 15, 6 times 15 is 90, 8 times 90 is 720. And then the user just pressed enter, so the program finished. Well, the only way this would work is if you're actually entering integers inside strings. So you actually have to have something like this here. Let's see if I can fire up idle here. You'd have to do something like this. Let's see, you'd have to say num. Obviously, I'm just in the interactive window here. But you wouldn't want to use the int function. So you could just say enter an integer. The integer is going to be actually inside of a string. Okay. So if I enter an integer, I'll enter, say, 12. And now, if I try to do some math with that, I can't. But I can if I change it to an int. So if for example, I say int num times 3, see, that's okay. But if I just did num times 3, I would have a problem. Let's see what happens if I just do num times 3. If I did just num times 3, I get 3 12s. Doesn't do mathematics. It gives me 3 instances of the string because what I entered was in a string. So the only way you can do that is enter integers, but enter them into a string using just input, not the int function and input. And then convert when you want to do the math. You have to convert like this with the int function. Does that help? I hope.
I think so.
Okay.
Yeah.
Yep.
Okay. Alrighty, I guess we're out of time. Have fun with this chapter. Loops are a lot of fun. I encourage you to try some of them other examples in the textbook with, that use turtle, by the way. It's a great way to learn how loops work. Let's see if I can go a bit overtime. Let's see if I can go a little bit overtime, if you don't mind. I'd like to try. Let's try another little program and see if we can do something useful. And I'm going to be really quick here. I'm not even going to give it a name. Just going to go to def main right away. No comments whatsoever. And let's say we want to print out a table of squares and cubes. So we could do something like this. We could say for n in range. Why don't we try using 1, I guess it's kind of silly. How about 2 to 10? And we'll have to make that 11 if we want to go from 2 to 10. So let's look at the numbers from 2 to 10. And let's calculate the square and the cube of both of those. So we could say SQ equals n times n. Or of course we could say n asterisk asterisk 2. But let's go with the cube equals n asterisk asterisk 3. That would cube the value of n, right? And then we could try to output a table. So we could say print. And why don't we try n? And then format the SQ variable in a column that's, how about, let's go with 6 characters wide. How about 6B for it? And then we'll also format after that the output of the cube.
Does it need the other quote?
Yep, it does. Thank you. The green is the tip off there, isn't it? The green color lets you know you haven't closed the string. So let's do this in a 8 characters wide column and close that quote. And let's go with just that. And this is going to print a new line after each line, of course, so that's fine. Let's just see what that does. Give it a try. I'll save this as a table when I give it a run here. So I could put it in desktop. I have a folder called PyLoops, so I'm going to call this one table. Hoping to get a table of squares and cubes. So we got there's one way to get left alignment. Print the first one without any formatting, and then the others with the formatting. Okay? Once again, just showing you how you can get a tremendous amount of output with just a little bit of code. Well, I guess we better go. I think I'm over time. So thank you. I hope you find this useful. Have fun coding your loops.
Thank you.
Thank you very much. Have a good night.
Take care. Take care. Bye-bye.